Hello and welcome to my channel. This is Trust Your Rusty Depot, and today we're going over ownership rules in Rust and how they help guarantee a safe program at runtime and help avoid bugs that a lot of people run into with other programming languages. So let's dive right into it. So Rust has a set of ownership rules, and these rules guarantee that the Rust program will be safe during runtime, and so that you don't run into any common programming bugs, such as data races, where two different parts of the program are trying to access the same memory at the same time, or when you try to free the same memory twice, which is called a double free. So instead of using a garbage collector where the program tries to identify when variables or values are no longer in use and cleans up the memory, instead Rust just chooses to drop a value as soon as it reaches the end of its scope. So for example, here we have a scope between two brackets, and if we create a variable here called num, we can use it anywhere within the scope. However, we can't use it outside of these two brackets, because as soon as this last bracket ends, this value is dropped, or it's freed from memory, so that we can't use it again. So if we try to use it here, it tells us that it can't be found in the scope, because we're outside of the scope where num was defined. Now, there are two different types of memory available to a Rust program. The first one is the stack, which think of it as like a stack of plates or pancakes, where whenever you want to add a value to the stack, it gets added at the top, and whichever gets added first is also the last one to get removed. So values are added to the stack and removed from the stack in the opposite order. There's also a second type of memory called the heap, and the heap is less organized. It's just a heap of memory, and in order to add something to the heap or allocate to the heap, the program needs to find a spot with big enough memory and save a pointer to that memory space on the stack. And so the stack is a lot faster to access. However, the heap can grow in size, while the stack has to be known at compile time and has to stay the same. So there are different types that get allocated in the heap or the stack, and a very good example of that are the two different types of strings in the Rust programming language. So the first type of string is called a stir, or an stir. It is stored on the stack, and so it's known at compile time, and it can't be mutated. It can't be changed. It's hard-coded, in other words. So we can create a stir by having double quotes around our text. So that would be a stir. And stir. Now the second type is a string, which is stored on the heap. It can be changed. Its size isn't known at compile time. We can create a string from an stir by saying string from, and then we put in the stir, so world. And a string can be changed, so we would be able to mutate it by saying mute and then saying string.push stir hello. Now, the ownership rules in Rust state that each value can only have one owner at a time, and its owner is the variable that is set to that value. So, for example, if we wanted to take this string and set it equal to another string, so string 2 equals to the first string we have. Now, if we wanted to use that first string again, it would give us an error because the first string, the ownership was moved into string 2, which means it was transferred ownership to string 2, and so we can't use the original string anymore. And that's because when we set string 2 equal to string, it copied only the reference to the memory in the heap, but not the whole memory itself. If we wanted to copy all of it, which would take longer, we would have to put a .clone here in order to copy all of the memory and not transfer ownership. However, if we try the same thing with stir, we can say stir2 equals stir. And then if we try to put println of the original stir, it doesn't give us an error. That's because since stir is stored on the stack, we can copy it quickly, and so it has the copy ability, or it implements copy, which means we can set stir2 to stir without moving it into stir2. So we're doing this without transferring ownership into the other variable. Now, this is similar to when we pass values into a function. For example, if we have a function called calculate length, and we say it takes in a string, we can do string.length and return usize. To learn about functions more in depth, check out my video about Rust functions. So now in the main function, we create a string, and then we return the length of the string with the function. So now that we did that, what if we want to print the string 1 again? Well, we can't because string 1 was already moved into this function. And when the scope ended at the end of these brackets, string was dropped out of memory. In sum, each value can only have one owner, and we can't use the old one again unless it was copied or cloned, and only values that are stored on the stack can be copied. So what are values that can be copied? Types that can be copied include booleans, integer types, floating point types, the char value, and also the tuple type if it contains types that can be copied. And for other types like the string, you would have to .clone here in order for it not to move this original value. In the next video, we will be covering how to use values without moving them into a new owner. And that's also a very main subject with the Rust programming language, and it's called references. In the future, I'm hoping to create a video with all that we've learned so far and to create a little mini project. So if you have any suggestions for mini projects for me to make, please leave them in the comments below. I'll be looking at your suggestions, trying to see what would be interesting to make. So without further ado, thank you for watching, and I will see you in the next video.